Hello again, everybody. And today I'm going to be teaching you Introduction to C, and this is primarily focused on teaching myself or brushing up my own concepts. Please do not expect me to know everything like a teacher does, or for that matter, any professional does. I'm still a student, and this will again. Let me reiterate. This is just a way to. Uh, make myself better at it, and while if it helps you, then please let me know, and it'll be helpful for me if it helps you as well, right? So let's just get started with C directly, and the first thing I'm going to do is write a header statement, and this just means that this is a header file, and hashtag include just tells the compiler to include a header file called stdio.h, where stdio stands for standard input output and .h just means that it's a header file, right? Then let's move on to the main statements, and this is called a function, and main is basically the function that's always executed first in the entire program, no matter what you write. Now before main, you might have noticed that there's an int. It just means that it's a return type. And of course, you can also put void here or float here. It really wouldn't matter. But the standard practice is either to use void or int. And in my case, I usually use int. So this is how it's going to be. Then usually the compiler already sets the default return value as 0, but it's a good practice to keep it in your head as well. So I'll be mentioning it anyway. Then the next one is going to be the types of data types. Now before that, actually, let me introduce you. Let me introduce you to a comment. This is a comment. Now, of course, a comment is something that is read by the compiler, but it's skipped anyway because it's a comment. And here, for example, this is a comment, and this is called a multi-line comment, where you can actually see that I'll be able to write multiple lines. So this is a comment one, this is a comment one, and this is a comment two. Now, usually you won't find me using multi-line comments as much, but I will be using single-line comments quite a lot, and it's a good practice. It's a good practice to explain the code as you go, right? Using comments, of course, using comments. Then moving on to the next one, it's going to be the data types. Now, this is how I'm going to start using comments. It's better for you as well as for me to remember what I'm doing. So the first one is called the integer data type, and I'm going to give it a variable name a. Then the next one is a float, which I'll be giving a b. The third one is double, which I'll be giving it as c, and there will be a character, which would be I'll be giving it as a ch. Now, of course, there are multiple types of data types in this case as well, but these are the four basic ones that you will probably be using the most. And of course, in this case, I'm going to be actually telling you what a, b, c, and ch are subject to change as they are variables. Now, uh, these are called variables, as you can see over here, a, b, c, and ch. This is primarily because of course, for me, I'm just explaining it right now, so let me just directly tell you that it is very important to remember what kind of important to know that you have to use the right variable names, right? This is because I remember that I had a really bad habit of actually using random variable names. For example, if a program asks you to compute simple interest, I just used to give int a b c d whatever, float a b c d whatever, as the names, and I just directly used to calculate it. Please do not do that. Use variables vars such as um sim interest or time, etc., just to basically keep you in notice, saying that use the right variable names. Use the right variable names. Now, as far as those are concerned, these are the types of data types, and these are comments. These are multi-line comments. I hope you've understood that. Now, moving on to the next part, this is probably also going to be one of the most used functions, and it's called a printf function. Now, before we get into all these, you might be noticing that I'm actually putting up a semicolon in after each and every line, and that's because in the C language, every line that you write, every argument that you write, every line, not argument, sorry, a line that you write, a logic that you write has to be ended with uh, a semicolon. Now, as opposed to a function does not need a function does not need a semicolon. Now, of course, although you can actually use it, though it really wouldn't matter. It just means for the compiler, the statement has ended there and it can go to a new function. And this is exactly why you can actually also combine multiple statements into single statement. This will still be valid. In this case, since one of the statements have already ended at the semicolon, the next statement has already started. This is how the compiler knows that double C is one statement and character ch is another statement assignment. Then moving on to the printf function, this is one of the functions that that are defined in standard input output.h. I'll be teaching functions, or in this case, I'll be learning functions in the upcoming videos. Although I have learned it, I just need to brush up my concepts. So I'll be visiting them again. So in this case, printf is the function that actually prints it onto the screen. In this case, this particular terminal is where I'll be printing it. Next, I'm going to printf something called hello world. Now, a lot of people might have the question, why always hello world? Now, this was just used as a standard in some cases. I think there was a story about Dennis Ritchie or some person. Dennis Ritchie is the person who made the C language, by the way, or some other person who actually just wrote hello world and it just became a standard from there. That's why I'll be using the standard hello world in this case as well, just to show it that this C language actually works, right? So for example, in this case, I'm just gonna go ahead and run the C file, and as you can see that this has actually printed hello world. Now, of course, this has not printed it in a new line, so there is actually, I'll give you the introduction to the new line character over here again. This is called the forward bracket, and I'm actually going to put a /n over here, and this will actually make it a new line. So let me just save that, and now I'm going to go ahead and run the C file. As you can see, this has already executed the word hello world, and this has already done what we want it to do. Now, I'm going to be teaching you about assignment now. I've already done, I think I've already done, yeah, I've already printed hello world onto the screen. Now I'll be going on to assignment. Now there are two ways that you can assign it. You can hard assign a variable. Let's say in this case a is equal to 10, and there is also something called a soft assignment, which I call it a soft assignment. Please do not mind that word being used here. When I say soft assignment, it just means that it's a variable assignment, and that can be done by the by the scanf function, which again is defined in the standard input output library. This in this case, I'm going to be giving this a B in this case, I think. Yeah. Now, let me just introduce you to these special characters: percentage %f, percentage %d. Let me just write that in a comment: percentage %f, percentage %f, percentage %d, percentage %i, percentage %c, percentage %s. These are just commonly used special characters that can be used in printf and scanf. I think that they can be used in other places as well, but I don't think I've done any programs that actually require it. So in this case, yes, printf, scanf, these are used in here. Now, percentage f just stands for a floating point. Yeah, of course. Percentage d stands for decimal. So does percentage I. Percentage I decimal, and what else? Of course, percentage LF is double. Long float in other cases. And percentage C is a character, and percentage S is a string. So in general, these are the general ones. So in this case, I'm basically taking the scanf, and I'm just basically taking an input of a percentage f and throwing it into the b variable. Now, then the very next question is, what the hell is a what is a and ampersand b? Now, ampersand just says that's an address, right? Now, in general, to understand how C programming works, you have to understand what an address is or what a pointer is. I'll be going on to the pointers and addresses later on in this particular course if it demands it or if I just feel like it. But in this case, ampersand is it just means an address. Now, every variable has an address on the system, uh, and that address is how you are going to store this particular number into that particular character. So now in this case, what happened is that you defined a floating point number b, and you're basically giving its address to scanf and you are basically and basically are sending the value percentage f to that address, effectively making it a value stored in that address, right? That's the best way I can explain it. And it's effectively like you getting an address, and then that address is now you, right? Now of course that's a very big oversimplification, but of course there's a lot of truth to that as well. Now, uh, uh, in a similar way, you can actually scanf percentage ch as well. See, I meant I'm gonna go ahead and do a ch over here, and of course, last but not the least, a double c. I'm just gonna give a c as a double value to 10.99, and now let me do a printf stating that I'm gonna print percentage d slash n. This is a decimal, and percentage n, then this is a floating point number, percentage f. Now I'm going to be telling you one more thing, and that's the number of floating point numbers that you are limiting it to after the decimal point. So for example, I'll say .2f. This just means that the floating point number will be extremely limited to just 2 points, or two values after the decimal point. I think in general by default it's around 6, or I think it's 6, but I'm going to be limiting it to .2 f. Then I'm gonna go ahead and create a new line. This is a character percentage c slash n. This is a double percent, and this is a double, again percentage lf. In this case, I'm gonna go ahead and actually write the values down. What do we do? A, B, C, and CH, right? Oh no, A, B, CH, and C. Yeah, A, B, CH, and C. Right. Again, this should end with a semicolon. Please do not forget that. Otherwise, yeah, it's gonna cause errors, right? So, let me run the code. And was there a problem? Output ports debug output for, yeah. So in this case, this is a scanf, right? So July, right? Actually, let me do it again. Actually, let me do it again, right? Yeah. Okay. Uh, so in this case, I've found the value introduction to C. Just a second. Yeah. So this has already printed hello world. Now it just moves on to defining a value. Let's say 90, right? The first thing that I did was scanf for a floating point number 90.8. Let's give it 90.8. And as you can see, this is a decimal 10, right? I think this is a floating point number 90.8. This is a character. I don't know why this did not show up, but in general, there's a nuance to it. Apparently it does not like a few I remember now. It's because of the new line. As far as I know, I think I have to leave a space here so that it works. Let me just try it again. 90.99 next. Somehow it doesn't work, but anyway, let's actually show it to you, right? So in this case, like I said, over here I left lf to be like that, and as you can see over here, it actually just printed it up to six decimal points. Here it was left for two decimal points. In this case, it was, as you can actually see, it was actually rounded off to two, right? 90.998 is interpreted as 91.00. If I actually go up to three decimal points, let's see what happens then, actually. So let me run it, and as you can see, 90.998, enter, and the character C. And as you can see, this is a character C. This is a floating point number 90.998. This is a decimal 10. I think I think here the last time I did not I did not run it, and that's why the previous ones weren't working. But as you can see, that this works now. It's because before the scanf file, I think as far as I remember, uh, the scanf does not like spaced characters. So when you put up a space before the percentage c, it's basically, the scanf basically eats up, so-called eats up the space, and lets you insert the character. I think this is all I can do for today. If it helps anyone, that's well and good. If it doesn't, I hope I hope I do better next time then. Uh right. So I'm just gonna give it a another run by just making small adjustments, right? In this case, I gave it a value 90.998. This is a decimal 10. This is a floating point number 90.998. Now if you like I said, if you do turn it into point 2 and save it, and actually just run the entire thing again, and I actually give it 90.998, and go on to the next one and give it a C, then you're gonna see that it has been rounded up. So it really depends on how much precision that you want. In general, now another thing to note is that if I give a dot 12 here and actually go ahead and run it again, uh, it's actually gonna create a small nuance. As you can see, random variables actually come up and get stored over here, which is not something that you'd want, but I'm just letting you know anyway. So in general, it's better to use long floating point numbers in places where you want high precision. In general, you don't, but it's a good way to really understand how these variables work. Another point to note before leaving you, I'm so sorry. There are so many points that I would like to cover up, but in any case, integer is actually, these all four different types of data types actually take up different storage values on a system. It's actually very system dependent. I'm running a 64-bit system, so I don't quite remember I don't quite remember what's the space or size taken up by each, but I'm just letting you know that this is exactly this is one of the things that you might want to know, that this might be 4 bits around, 4 bytes, sorry, of course. This might be 4 bytes, this might be, I think, 8 bytes, and double is like 10 or 16 bytes as far as I know, and character is again 4 bytes again. So these actually makes if it makes sense to you, it makes sense to you. If it doesn't, this is probably going to be taught to you later anyway. So thanks for watching. Catch you guys in the next one. Peace. Yeah, I just stole MKBHD's line. Thank you.